Machine learning is getting more and more important in the field of automation. We're now going to give you an overview of how Beckhoff integrates machine learning into its Beckhoff system. Fabian, can you give us an overview of machine learning and position it for us in the field of automation?
Yeah, sure. So I think best is to, first of all, introduce in kind of several examples. For example, customers already successfully integrated machine learning in our Twincat software for the purpose of quality control, and which is in particular very important in high volume production systems. So assume you have hundreds of products that you produce, and it's not possible or nearly not possible to inspect all different products using a human being. So what you can do is you can just inspect maybe every 1,000 product or every 10th product, but best would be to just inspect every single product, which means you need to automate the quality inspection process. And machine learning is a very nice tool for solving problems like these. Other applications we touched so far with our customers is, for example, process monitoring in process industry, or machine optimization. So basically you can try to learn an algorithm that is able to predict favorable machine parameterizations to achieve higher productivity or better product quality results. Other customers, for example, try to combine already existing Beckhoff products like Twincat machine learning or Twincat condition monitoring with machine learning for the purpose of visual inspection, for example, in combination with vision, or with predictive maintenance in combination with our condition monitoring toolbox. So overall, the interest in machine learning is very, very high, and we are happy to support you as best as we can.
Okay, Fabian, so we have a lot of customers that have already been using our machine learning capabilities. We have successfully realized projects together with some of our customers, as you've just explained. Now, how do we really integrate machine learning into the Beckhoff system, into Twincat? What are the products that actually customers will be able to find?
Yeah, so to explain the exact product, I'm going to change to this slide here. So basically what we did is we integrated machine learning inference directly into the machine control. So basically speaking, you are able to load already trained machine learning models like neural networks or support vector machines directly into our Twincat environment and just execute them. So if we have a look on this slide here, we have an overview about the Twincat 3 runtime component. So what we did is we created a TCCOM object that is able to load trained model files. And this trained model files is the ONNX, which is a standardized file format for already trained machine learning algorithms. So as you can see, you can directly interact with this TCCOM module that is able to load machine learning models directly from the PLC or the C++ world. So this module is integral part of the complete control application. So you have in real time access to all relevant data of the machine because you're centrally placed in the machine control.
Fabian, what benefit does it give to the application being able to run and execute the machine learning algorithm in real time into the controller?
Being able to react in hard real time enables us to discard or sort out products while they just run through the machine, so on the fly. So we know where those products are in the production line, and we have in real time the trigger. Here I need to sort out the products. Furthermore, we are able to use the complete capabilities of Twincat. For example, in terms of connectivity. We are able to parameterize Twincat such that we can act as a field bus slave and couple directly to Ethernet IP or to Profinet. On the other hand, we can make use of all IT protocols that we are able to speak to communicate with IT systems in the automation pyramid. In addition to that, we don't require any additional hardware. We run on our industrial PCs where you just run Twincat for the last 20 years. This is the same hardware that we now use to also run machine learning models. What we use are the modern instruction sets that are available on modern CPU architectures like those from Intel and AMD.
We've now seen how machine learning is integrated into Twincat and how it works. Fabian, you spoke about this ONNX format. How do we use it, and what exactly is it?
To understand what ONNX basically is and where does it come from, we need to have a look on the complete cycle of database processes. So on this side, we see the first stage, the data acquisition phase. So machine learning always relies on data, so you need to be able to log data. On the other hand, we see here the training phase. So we need to be able to load in the data into a framework that is able to create and to train a model to fulfill some tasks. And the third stage then is to load this model that you created in your training phase, for example, in a Python environment, into Twincat, and this is then the inference phase. This cycle is per definition a closed cycle, so you do not just start logging data, train something, and plug it back into the automation world. It's an ongoing process, so you always log data, and you can retrain your algorithm based on more data, on different situations, and you can bring in this newly created model into the Twincat world.
Okay, Fabian. But, I mean, if we start with the data acquisition, somehow I need to know what data I have to select and which data I have to pass on. So how does this process really start?
The process, of course, starts with an idea or with a business model. Let's, for example, have a look on this example of quality control. What you want to achieve is, for example, you want to be able to check the quality of every single product while having a very high productivity rate. So it's more or less nearly impossible to control every product by hand. So what you want to achieve is an automated quality check process. And for example, you start with this idea, okay, I need to identify what signals in my machine are relevant for this quality, for example. So I'm pretty sure for many cases the environment temperature doesn't have any effect, but those parameters or signal which are relevant for the interaction between product and machine are relevant. For example, the motor currents. Those signals are for example, very interesting to investigate. So what you search for in the first phase is you need to search for data that has a sensitivity to your goal. So if I have a change in my target function, for example, good or bad product, I also need to search for some deviation in the underlying data. So for example, if I have a peak in my motor current, and always if I have a peak, I have, for example, produced a bad product. So this is what I'm searching for. In particular, what we start with is a so-called design sprint. So you capture data, so just the first shot, and you start a very agile process. So you're searching for a prototype implementation of different kinds of models that are able to achieve what you're searching for. So this is, as I said, an agile process. So some prototypes may lead to nothing. Others may show that we have the possibility, based on the data that we captured, to realize, for example, a quality control instance in the machine. Based on a good idea or a good prototype, we can then start the product development cycle. So this is then firstly driven by much more data to be acquired from the system. So you need to acquire data from the machine in different situations. Maybe you run the machine in different parameter sets or higher or lower productivity. So all those situations that may occur during the lifetime of the machine should be included in this data set. So basically, your model should see everything up front that may happen during the lifetime of the machine.
So we've now seen the theoretical and important aspects of the data acquisition process. But Fabian, for the practical aspects, what kind of tools and what kind of technology do we offer to support customers acquiring the data?
That's a very good question. So we offer many different products for data acquisition. So why do we have so many different products? This is because we are facing many different situations. So for example, you are targeting a greenfield scenario. So you hook up a new machine and you can just choose from scratch. So what tool you want to use for data logging. Maybe you are facing a brownfield scenario. So you are targeting a scenario where many aspects of the complete implementation are already fixed, and you just need to somehow fit into this given puzzle. Furthermore, it's also important what target I want to achieve. Do I want to have a long-term recording or just a short-term shot of, for example, my design sprint? If I want to have long-term recordings, for example, the analytics logger or the database server are very nice tools to achieve long-term recordings. On the other hand, if you want to have a short-term shot for the first insight into the data, the scope, the Twincat scope, which is integrated in every Twincat engineering environment, is a very nice and handy tool. Other aspects to think about are what storage medium I want to target. So do I have a file system where I can log, for example, CSV files or TDMS files? Or do I have an SQL or time series database somewhere which I can just fill? Or do I have a complete cloud system which I can connect to my machine? So those are very different scenarios. And for all those scenarios, we offer different kinds of products. In addition to that, you always have to think about the IT requirements where on the side where you place the machine. So, for example, several ports may be blocked. So maybe the outgoing MQTT port is blocked. So then you cannot just speak MQTT, or you need to search for an open port where you can switch to. Maybe you have access to an SQL database in the network or not. Maybe this network is departed into several sub-networks. And so it's very, very important at this stage to think about IT requirements, IT security. I also want to emphasize one very important point here, which is the integration of data acquisition API into the control logic, into the PLC. If you're able to trigger the data acquisition directly from the machine control, you're not only able to just log a time series from time point 1 to time point 2, but you're able to log process frames. So you exactly know when a process starts and when a process stops. So you can just log this episode or this time frame. Maybe the process has varying duration times. So in this case, it's very helpful to directly integrate this also into the process or in the control.
Okay, Fabian, so we've now seen actually how we can gather the data. And prior to that, we have decided upon a target that we want to achieve with the whole project. So now with this data that we have collected, who do we pass it on to and what do we do with it?
Yes, so here we leave now the domain of automation and enter the domain of data science. So what we now do is we pass on the data to another team member, maybe who is familiar with data science. And the data scientist will work in different kind of frameworks like Python, R, or MATLAB, which are scripting languages. The automation engineers are working in other frameworks like Twincat, so they are used to think in cyclic execution and PLC coding. In the data science, we are facing scripting languages, so it's a complete different world. And so we want to keep this this freedom of the choice of the scripting language at the data scientist side. So we don't say you have to use this or that product or this and that framework for the learning process. We just keep it completely open. And so the data scientist can use his framework of choice, for example, PyTorch inside a Python environment, read in the data. The data scientist can do his job. He can evaluate the data, clean the data, model some algorithm, and train. And in the end, he's able to export this trained model as an ONNX file. By promoting this openness in terms of the choice of the framework that the data scientists can use, our customers directly benefit from further development in the data science world. For example, if the data science community implements software for labeling of data in an open source framework, the data scientists can directly make use out of it. Or for example, if additional functionality, for example, AutoML is coming into a framework like TensorFlow or Keras, he can just directly use it. So we don't limit it. We don't have to transport the new developments from the data science into automation, but the data scientist can just keep track and have a look on his tools that he's using and directly use the new developments.
So before we go on, let's recap briefly. So first, we have set ourselves a target. We found out what we want to achieve. We found out what data we wanted to acquire. And we have passed on that data to the data scientist. Now, the data scientist has created a model, trained the model, and now he is creating an ONNX file. And this ONNX file is now going to be handed over again to the automation guys, as Fabian explained. So Fabian, how do we at Beckhoff and in Twincat integrate actually the ONNX file?
Well, this is quite simple. So basically, you just need to load in ONNX into the Twincat engineering. And in the Twincat engineering, you're, for example, also able to add more information to the model, like the version number. Then you just write your PLC code and download the code to your IPC. And you need just to place this description file also on the same IPC. In your source code, you have, for example, a PLC function blocks that you can use and just trigger the configure method. And this will then load from the file system of the target IPC the file. And then the function block knows what he is supposed to do. For example, he's able then to find anomalies in your process. Using the prediction method, you execute this model. So this is rather simple. So you just get the ONNX, you are able to add more content, meta information to this model. You place it on the file system of your IPC, on your target PC, and you make use out of it, for example, by using our PLC API. if you want to do an update of your machine learning model during runtime of the machine, this is also the same process that you have to go through. So you get a new Onyx file, you, for example, iterate the version number, you download this description file to the file system of the IPC, and where Twincat is still in run mode, and then you could only need to trigger the configure method again. And while Twincat is running, we will load in the new description file and make it available for the prediction method of our function block. So this enables you to update constantly all the time. Maybe you want to update because you have a new functionality. More, for example, you can now decide between more different situations, or you want to update because you have a more precise model of your application.
This seems to be quite a comprehensive process, Fabian. So can you also let us know, how do we at Beckhoff actually support customers in going through this process? Because to a lot of our customers out there, it might not be that trivial.
So we offer to our customers different levels of support. So of course, we have our broad experience in the field of automation. So here we offer our well-known support to our customers. And in particular, we also support you in the design of your machine learning model. So we also support you in this area of the data science. If you're looking for a comprehensive service of your machine learning project, we are also happy to work together with third-party companies. Maybe you already have contact to a data science company, and you can connect this company to us, and we sit down on a round table with these three parties. If you do not have a data science company at hand, just send us a note, and we can connect you to well-known data science companies with whom we already successfully created data science projects.
Well, Fabian, that was a lot of information. Can you please recap that for us?
So I think the most important points are that we have an integrated inference engine in our Twincat environment, which runs on our standard IPCs. So you are able to load in your machine learning model, for example, a support vector machine or a neural network, and execute this algorithm directly inside of our Twincat system, which gives us the possibility to directly interact in real time with the machine. So if you have any more questions, just feel free to contact us or visit us on the internet under beckhoff.ai.